Hi everybody, welcome to another video in linear algebra, section 1.2, row reduction and echelon forms. So from previous section, we learned that we can associate a system of equation to the augmented matrix. And we also learned that to solve the system of equation, we can keep that in the matrix form and do some operation to turn that into the matrix in this form, and that is the solution. And these are the operations that we can use. Those are the elementary row operation. But on the previous section, we did not learn how to go from that matrix to that matrix. And that's what we learned in this section. First, echelon form. Should be echelon forms because there will be more than one. Right. So echelon. So I just go on Google and type what is echelon formation. Let's say in military. So have some picture like this. So to see the echelon is like steps in that direction. Let's just say from northwest, southeast direction. So that is the echelon formation. Right. Now we go back to what we mean when we say echelon form for a matrix. So rectangular matrix is in echelon form or row echelon form if it has the following properties. All non-zero rows are above any rows of 0. So if we have rows of 0, those will stay at the bottom. Next, each non-zero leading entry of a row is in the column to the right of the leading entry of the row above it, meaning that if we have a row that is called the leading entry in a row, and the one on the row below it have to be on the right of it. So the leading entry for each row, we're shifting to the right. It doesn't have to be immediately on the right. It could be on the way here. So this is called the echelon form. For each row, we go down, we move to the right. Maybe one spot or two spots, but have to be on the right of the one above. And then all entries in the column below it have to be 0. So when we have that, everything below it have to be 0. So this is an example of an echelon form matrix. Once again, non-zero entry, those are the leading entry, and they have to align in the echelon formation. Right. Now, furthermore, if the matrix is in the echelon form, so if it is in this form and will require additional properties, then we will have reduced echelon form or reduced row echelon form with additional conditions. So the additional condition is that the leading entry have to be 1. So instead of the non-zero entry for the echelon form, it has to be 1 in the reduced row echelon form. And each leading one is the only non-zero entry in this column, meaning not only they have 0 below it, they have to have 0 above it. And then we have to have 1 on the entry. So if this is in the echelon form, then this will be in the reduced row echelon form. Instead of any non-zero number, it has to be 1. And so we have 1 for the leading the leading entry, and then 0 below it and 0 above it. Yeah, doesn't matter what between here, but this is a sample of reduced row echelon form. So you see the difference between the two. And and the echelon matrix is in one of those form. I mean, echelon matrix is for the echelon form, and the reduced echelon matrix is for the reduced row echelon form. Right, so we see the difference of the two. And uniqueness, each matrix is row equivalent to one and only one reduced echelon form, or reduced echelon matrix. Row equivalent meaning that we can use the row operation to go from one to another. Right, definition. Now this is just like what we have here. If A is the row equivalent to echelon matrix U, we can use the echelon form of A, and then it's just the terminology. Right. What's important here is terminology, the pivot. The pivot position of the matrix A corresponding to the leading one, meaning corresponding to the leading one of the reduced row echelon form. A pivot column is the column that contains a pivot position. So in this case, we call the one here the pivot entry, and the column is called the pivot column for that column. Regardless, doesn't matter what we have in this column, because we cannot have. This has to be 0, because this is the leading one, the first entry on that row that is not equal to 0. So yeah, it doesn't matter, because there is no leading one. There is not a pivot column, therefore it can be anything else. Right, so we have the pivot entry, or just a pivot is the position. The values of that, of course, is 1 in the reduced row echelon form. The pivot column, of course, is contain that pivot entry. Right, here are some example of the echelon form. So this is in echelon form. The leading 0, leading that square, meaning it could be any non-zero number. The star meaning it can be anything. Right, so this matrix, let's say Y is that an echelon form. So for each row, we will put the box around the first non-zero entry, right? This row, that is the first non-zero entry. This row, the first non-zero entry. This one is the first non-zero entry. Alright. And then next, it is on the echelon formation. So that's good. And then we don't have any row of 0. So that's good. So that's why this is in the echelon form. Next, we have that non-zero entry on the echelon formation. If we have a row of 0 at the bottom, perfectly fine. At the row of 0 at the bottom doesn't affect anything, because there's no leading entry here, no pivot entry on the row of zeros. Right, so echelon formation, good. This also echelon formation. So that's good. So it is in the echelon form. Now, the next matrices are in reduced row echelon form. So in that case, we look for the first non-zero entry. So this, we have this one, the first non-zero entry, the first non-zero entry. All of that are 1. So that is the criteria for the reduced row echelon form in the echelon formation. So that's good. And so yeah, so this is in reduced row echelon form. Even though if we have, let's say if there's a 2 here, it is perfectly fine, because it is not a pivot column. Once again, we have 1 leading ally in echelon formation. Good. Anything below it is 0. Anything above it is 0. This is none. It's not a pivot column. It could be anything. So that's why if there's a 2 here, perfectly fine. but that cannot be something else, because in the reduced row echelon form, every pivot column there's only one in there. It cannot be anything else. Everything else have to be 0. Only one at the pivot position. Right. This one, we have the 1 here. It's the leading 1. The first entry that's not 0 is 1. It aligns on the echelon formation, which is good. However, this is a mistake here. This, if it is in reduced row echelon form, this has to be 0, because every entry in the pivot column except for the pivot entry itself has to be equal to 0. So if we want this to be a reduced row echelon form, that has to be 0. Right? These are not pivot columns. Doesn't matter. Right. Next one. First non-zero entry. This is first non-zero entry. Alright. Good. They align on the echelon formation. Good. And for every pivot column, we only have 1. Everything else is 0. This is not pivot column. Doesn't matter. This is pivot column. We have 1 at the pivot, 0 everywhere else. Good. We have 1 at the pivot, 0 everywhere else. It's good. This is not a pivot column. Doesn't matter. Right. So I hope you will see the difference between the echelon form and the reduced row echelon form. Right. Now, how do we turn a matrix into a reduced row echelon form? Right. This is the algorithm to turn a matrix into echelon form. Alright. First, we obtain the non-leading entry. We obtain the pivot. Then create only 0 below it. That's simple enough, right? So first, when we look at this, and then we say, for that matrix, that had to be something else, right? So this have to turn into a pivot. So let me just say this. We're going to turn this into a pivot, meaning that it is not going to be 0. We turn that to something else, because the echelon form will start that entry. Right. To do this, there are a lot of different ways. We can swap the first and the second row. In that case, the -1 will go in there. Or we can swap the -2, the third row into it, or the fourth row into it. What I do instead, if there's 1, I prefer to just switch the 1. To get this into the pivot entry, what we do is going to swap row 1 and row 4. By the way, I don't know how long is this from. I just fold the page in half in case we need more space. Right, so swap row 1 and row 4. So that's easy. By the way, I'm going to do by hand, and then we're going to use the calculator. So we swap row 1 and row 4. So row 4, 1, 4, 5, -9, -7. And then row 4, row 1 to 4, so I have 0, -3, -6, 4, and 9, right? And then row 2 and 3 will stay the same. And then you say, does it have to be a augmented matrix? It doesn't matter. It could be for any matrix, so we don't even need to. This doesn't have to be a augmented matrix. It could be anyone, right? So again, I will use the calculator to keep track of what we doing. So I'm just going to go to matrix, and I'm just going to use the calculator. By the way, do not get too hung up on this. At the end of the section, we just jump straight to it. We don't have to do every single step in this. And if you don't have the calculator, don't worry. I show you a website that can do this. Right, so now I'm just enter this matrix here. If I use DI84, that alpha zoom, this one 3 rows, 5 columns. Right, so we need the matrix, enter the numbers 0, -3, -6. Don't hit enter though, just move to the next cell, 4, 9, -1. Oh. Can even count 4 rows and 5 columns. Right, once again, 0, -3, -6, 4, and 9, -1, -2, -1, 3 and 1, and then -2, -3, 0, 3, and -1, and then 1, 4, 5, -9, and -7. Yeah, I just want to swap row 1 and 4, so that's just going to be positive 1 there. So that's all. Right, so that is the matrix. Now I have to hit enter when we finish the matrix. Right, now we swap row 1 and 4. So second matrix, go to math, swap, row swap. So what we do is we're going to apply to this matrix, right? So second answer. So that's why when we enter the matrix, we hit enter, so we store the answer as the matrix. We're going to swap row 1 and 4. Right, 1, 4, 5, -9, -7, -1, -3, 1. Right, next. Right, so we obtain the pivot entry. So now we just do the check mark here, the pivot entry. We have the pivot. Good. Next, we're going to turn that, everything below that to 0. So we're going to turn this entry to 0. Right, so how do we turn that to 0? Well, if you go back to what we did on the previous section, if we want to turn something to 0 from the here to here, we're going to do elimination. So pretty much what we do is if we multiply opposite to this number, opposite of -1 is 1. Multiply 1 into the pivot row, the row that contains the pivot entry. So what we do is we're going to take 1, which is opposite to this number, multiply to that, which is row 1, and add to row 2, replace to row 2. So in this case, row 2 will change, 1, 2, and 4 will stay the same. Right, I have 1, 4, 5, -9, -7. Remember, only row 2 will change. The other 3 rows will stay the same. Alright. 1 times row 1. 1 times 1 is 1 plus -1. That will be 0. 1 times 4 is 4 minus 3. Sorry. Apply to row 2, so it's much better. Just let's do that. Okay. 1 times 4 is 4, and that minus 2. 4 minus 2 is 2. And then 1 times 5 is 5 minus 1 is 4. 1 times -9 is -9 plus 3, -6. And 1 times -7, -7 plus 1, -6. Right. So on the calculator, second matrix, go to this option. We will multiply 1, apply to the matrix, multiply 1 into row 1 and add to row 2. Right. Right. So let's check. We have the 1, the pivot, which is good. We have 0 below, that is good. But this have to turn to 0. The -2 have to turn 0. And to turn to 0, we use elimination. So opposite to that number is going to be 2. Multiply to the pivot row 1. Add to row 3. Replace to row 3. So doing that, only row 3 will change. 1, 2, and 4 will stay the same. And row 4 will stay the same. Now, 2 times row 1. 2 times 1 is 2 minus 2. That's going to be 0. 2 times 2 times 4 is 8 minus 3 is 5. 2 times 5, 10. 0 is 10. 2 times -9, -18, -6, -24. I'm sorry. 2 times -9, -18. 3, that should be -15. And 2 times -7 is -14, and -1, -15. Right, so that is new row 3. Again, I will check with the calculator. So multiply 2, apply to the matrix, multiply 2 to row 1, add and replace to row 3. Right, so 1, 4, 5, -9, -7, 0, 2, 4, -6, -6, 0, 5, 10, -15, -15, 0, -3, -6. Right, that's good. Right, now let's check. The first column we have the pivot entry. So that's 1 is good. Everything else is 0. So that's also good. So the first column is good. Now go to the second. So we're done with that. The first pivot, the row column. So it's good. Now we're going to turn Is this a non-zero? So that's good. Yes, it is non-zero. Yeah, just keep that as a pivot. We're going to turn this to 0, and we're going to turn this to 0. Right. So in order to turn, we're going to need to turn this to 0, and later on we turn this to 0. When we get used to this, we can do both of those operations at the same time. Yeah, but now let's just keep do that. So in that case, 1, 2, and 4 will stay the same. Only row 3 will change. So what we do here is to turn the 5 to 0, meaning how do we do that? Of course, we're going to multiply by 2.5 here and add to that, right? In order to get to a negative 5, we have to 5 divided by 2 is 2.5. So it's negative 2.5 multiply to row 2, add to row 3, replace to row 3. Right. I hope we have enough space. Right. Just do that. Right. So only row 3 will change. 1, 2, and 4 will stay the same. Like I said at the end of the section, we just use the calculator to go from the first to the last step. We don't have to do this every single time. But I still want to do this, so we don't get that on the screen. Let me zoom out. Yep, that will do. So first, row 1 and 2 will stay the same. Row 3 will change, and row 4 will stay the same. Now, row 3. Negative 2.5 times 2 is negative 5, plus 5 will be 0. Of course, that we have 0 here and 0 here. Negative 2.5 times 4, that's negative 10, plus 10, or that's 0 as well. Negative 2.5 times negative 2.5 times negative 6, that would be 15, and so that would be 0. And negative 2.5 times negative 6 is also 15, and that will be 0. So what we do is negative 2.5 apply to the matrix. Negative 2.5 times row 2 plus row 3 and store into row 3. Right, so we have what? 1, 4, 5, negative 9, negative 7, 0, 2, 4, negative 6. Right. Here we have a row of 0. That row of 0 should be at the bottom. So here let's do the swap row 2 and 3 and 4. Three and 4 will be swapped. Row 1 and 2 will stay the same. This is not the best way to do it. Now 3 and 4. So we have the row 0 and then row 3. Now let's check. The pivot here is good. Everything else 0. Everything below is 0. Next, we do have the pivot. It's not 1, but at least an entry. Now we need this to be 0. From 2, what we have to multiply to get to opposite number to that. So 2 times 3 half, right? If we multiply by negative 3 by 3 half, sorry, positive 3 half, to row 2, because that is the pivot, we multiply based on the pivot, so that we have the number opposite to negative 3, so we multiply by 3 half, add to row 3 and store into row 3. Right. I will just use a calculator here. Right, 3 halves, apply to the matrix, row 2, add it and replace to row 3. Right. What did we forgot? Right. We forgot to swap row 3 and 4. Okay. So what happened here is, can we copy and paste here? Oh, I cannot do that. Right. Of course, if we at any stage we make something wrong, of course, don't continue with this. Just enter enter the matrix at the last stage. All right, I'm going to enter this back in. Right. So that's what happened when we make a mistake. Just have to enter the matrix at that stage. So that is the advantage of write everything down, and so when we have a mistake, we just continue from the last thing that we wrote down. Like I said, we do not do this on every problem. Right, 1, 4, 5, negative 9, 7, 0, 2, 4. Right. Now we're going to do that. Yeah, I just forgot to do the row swap here. Right, 3 over 2. Apply to that last matrix, we just enter, and then multiply to row 2, add and replace to row 3. Right, and so we have that. Let's write that down. Let's check the pivot of the leading entry. Everything below that 0 is good, good, good. On to the next row, the non-zero on the right side on the echelon, which is good. Everything below that, good. The next row we have the pivot is here, which is good. I mean, by pivot I mean the non-zero entry, which is good. And then below that is 0, which is good. And the last row of 0, which is good. So yes, this is in row echelon form. Yeah, don't worry, we only do this a few times in this section, and after that we just get the calculator to go from here to there. It's not even here, it's even better than this, but that's what we do. So the idea is get the pivot, the non-zero entry first, and then we turn everything below that to 0. Right. Next, how do we turn the matrix into reduced echelon form? Right. So in that case, what we do is, one, we have the entry, turn that into 1, and then turn everything above to 0, because we can it is easier to get 1 first and turn to 0. Right. Like I said, we still need to do a few of them by hand. After that, just use a calculator, but it's a very good practice. Right. Now, let's say we have this. Right. So first, we need the non-zero entry there. So this need to be a pivot, a non-zero entry. So I'm going to turn that to something else other than 0. So it's easy. Why don't we swap row 2 and row 1? Once again, I don't know how long the problem is. So just right on the half space, so we have more space to do it. Right, swap row 1 and row 2. By the way, this is sample in the book. There's no need to have the matrix that have 6 columns like this. Right, and then row 1, row 3 will stay the same. Right. Once again, I'm going to use a calculator. Just make sure that I do the math correctly. Matrix. Okay, this only go up to 6. If it's more than 6, we have luck. By the way, if this is more than 6, what we need to do is second matrix here. And let's see how. Yeah, I think you can go to 10. Yeah, you can have a very big matrix here if we want to. But alpha zoom, we can only go up to 6 on the home screen, which is fine. Right, 3 rows, 6 column. Right, 3. Yeah, just enter the original 0, 3, negative 6, 6, 4, negative 5, 3, negative 7, 8, negative 5, 8, and 9. 3, negative 9, 12, and negative 9, 6, and 15. Right. 0, 3, 3, 3, negative 7, negative 9, negative 6, 8, 12, 6, negative 5, negative 9, 4, 8, 6, negative 5, 9, 15. Alright, that's good. Now, swap row 1 and 2, second matrix. Row swap the matrix, row 1 and 2. Alright. Right. Next, we have the pivot entry or the non-leading 0. 0 below that is good. Now this need to be 0. To do that, we just multiply by negative 1. That will do the elimination nicely, right? So we'll do negative 1 times row 1 plus row 3 and store into row 3. Right, so we eliminate this. So every time we want to eliminate something, we will multiply to the row that has the pivot entry. Multiply something so the number will be opposite. Like I said, later on we will have a much better way to do this. Right, so we will do that. And so what do we have? I'm just going to use the calculator here. We have negative 1 matrix, multiply to row 1 and add and replace to row 3. Right. It's almost easier to write in column when we have the big matrix like this. And why do we have to write this down? As you see in the last problem, if there's something wrong, we know where we can continue. Right. Right. So, what do we have? That check, 0 below that check. Now this need to be, actually this is non-zero, which is check. Now we just need to turn this to 0. Right. So we'll, in that case, we'll multiply to the pivot row. So multiply something to row 2. And when add to row 3, replace to row 3, that we eliminate. So what do we multiply to 3? That gives us negative 2. So that will be negative 2 third or 2 third. 2 and 3 cancel. 2/3 times 3, 3 and 3 cancel, 2 and -2, that gives us 0. Yeah. Like I said, there's a better way to do this. But here we will do 2/3, apply to the matrix, multiply to row 3, add to row 3, replace to row 3. Alright. Okay, one more thing though. When we do this, we only multiply and divide. The answer can be written in fraction. So if you have the decimal like that, hit math. Now we have fraction. Check. Right, now let's check. Because that check, we have 3, check. I mean something other than 0 to check, below that 0 check, and then on the last row, check. So this is in reduce in row echelon form. Right, next, if we want to turn this into the reduced row echelon form, first on the entry here is going to be 1, right? So I just going to multiply 1/3 here to row 1, multiply 1/3 to row 2, and multiply by 3/2 in here. So that will turn on the entry here to 1, right? So now we have the in the row echelon form, just do that. So I will do 3, I will write 3 at the same time. Yeah, what we do in class is not even this, what we do is something else, but this is what we have originally. Right, so in the reduced row echelon form, this has to be 1, so we're going to do 1/3, row 1, go to row 1, and then we do 1/3 row 2, start to row 2, and then 3/2 of row 3, start to row 3. Once we do all of that on the leading entry will turn into 1, right? Keep the calculator here, second matrix, let's do that first. We just multiply, so we're just going to use that. Multiply 1/3 to the matrix, add row 1. Skip that. Now we do 1/3, apply to the matrix, multiply to row 2. Alright, give that. Three halves, apply to the matrix, and that is row 3. Alright, now let's change this to fraction. One negative 7 over 3, 8 over 3, negative 5 over 3, 8 over 3. There's a better way to do this, don't worry. Zero, 1, negative 2, 2, 4 third, and negative 5 third. And then everything will be 0, 0, 0, 0, 1, and 4. Right. So we do have the pivot entry, the leading entry now become 1, which is good. Now what we need is, because we deal through echelon form, everything in that column have to be 0. So I'm going to turn this to 0 first, which we do is, if we want to turn something to 0, we base on the pivot here. So the pivot is at row 2, so we multiply something to row 2, add and replace to row 1 to eliminate. And we're going to use the number opposite to this. So second matrix, seven over 3, apply to the matrix, row 2, and add replace to row 1. Then decimal here, change the fraction. Right, don't worry, just write down 1, 0, negative 2, 3, 52 over 9, negative 8 over 9. The step to go from the original to the final state, there are a lot of different ways to do that. Sometimes we have the fraction, sometimes we may avoid it. But this happens to have fraction. Still fine though. Right, now what do we need? Well, pivot entry, there, everything else 0. Pivot entry, everything in that column 0. Good. Now on this pivot entry, this have to be 0, this have to be 0. And to do that, we have to base on the pivot, which is on row 3. If we want to turn that to 0, we only use opposite to that. Multiply to the pivot row and add, replace to row 1. At the same time, we will, and to turn the 4 third to 0, we're going to use opposite to that. Multiply to the pivot row, which is the row containing the pivot entry, row 3, add to row 2 and replace to row 2. Alright, let's do those two. Second matrix, negative 52 over 9, apply to the matrix, multiply to row 3, add and replace to row 1. Right, And now we do this second matrix. Negative 4/3. Apply to the matrix. Multiply to row 3, add and replace to row 2. Right. Yeah, even though we have a bunch of fraction in the middle, now we don't have any more fraction. So that looks like a good sign. Now, the final check. Pivot entry, everything in that column is 0. Good. Pivot entry, everything on that column is 0, which is good. The pivot entry here, everything on that column is 0. So that's good. This is not the pivot column, so it doesn't matter. So this one is in the reduced row echelon form. Reduced row echelon form. Like that, we're not going to even do exactly like this. There's a much better way to do that. Even if we have to do by hand, it's called the Gauss Jordan elimination. But what we do instead, we separate into two phases. The first one to go here to echelon form, that called the forward phase. And the step that go from the echelon form to reduce row echelon form is called the backward phase. So the forward is we go from the original matrix to the row echelon form. We call the REF. And then the backward phase is from the echelon form to reduce row echelon form. And perhaps you say, RREF, did we see that on the calculator? Yes, this is here. So if we want the matrix to reduce row echelon form, yeah, just go with that and enter the matrix. I'll try to enter that as much fast as I can. Right. As you see, the calculator, when we use REF, we go from the first matrix to the last one without any problem. So because we have the calculator, we don't even need to stop at the echelon form. We can just go straight to reduce row echelon form. By the way, just on the previous page, the echelon form refer to the row echelon form, and the reduced echelon form is reduce row reduce echelon form. By the way, the row echelon form is not unique. So if we use, instead of REF and instead of that, and we use REF, see, we got something else other than this, because the way the book defines the echelon form is different than what we have here. What will be the same is the reduced row echelon form is unique. So reduced row echelon form is unique, and that's why when it's pretty much 90% of the math that we use the calculator on. When we have the calculator, we do 90% of the time to do any problem. In this class, we just turn that into the reduced row echelon form, because that is unique, unlike the row echelon form. Right. So what happens if you don't have the calculator? Well, if you don't have a calculator, just go to the website. I will put this link in the learning materials, and in that case we just enter the matrix. Skip a space. And we want to have exact answer. When we do that, when we're done, just hit calculate. It will give us the reduced row echelon form for the matrix. So if you don't have a calculator, you can use this website, which will be available when you take the test. You can use this website. This the only website we can use. Of course, these are the steps that they do to get to the final answer. Right. So that. By the way, I did mention that we will, this is not a very good way to do it. What the more efficient way, more compact and easy to remember, is called the Gauss-Jordan elimination. What it does is that when we have the matrix, first we're going to turn the pivot, get the pivot entry to 1, obtain the pivot 1, and then turn everything in that column to 0 before it and after it to 0. Get the 1, turn everything to 0, get the 1, turn everything on that column to 0. We're done. So Gauss-Jordan elimination, only 2 things to consider. Get the 1, the pivot entry, and based on that 1, eliminate everything in that column to 0. Right. Now, let's do this couple of samples by hand. Of course, now we know we just put the whole thing in the calculator and do the RREF and we're done, right? But like I said, just practice. What we call here is Gauss-Jordan elimination. Right, Gauss-Jordan elimination, meaning just get the 1 first, the pivot entry, everything else on that column will turn to 0. So this is 0. Already got that, just good. Now turn this into 0. Now, the reason where we have the 1 at the pivot, it is easy to eliminate, right? Now we know we need the pivot, which is row 1. We're going to eliminate the element in row 3. But what do we need to multiply to that entry to eliminate this? If it is 1, it's easy. To get to 5, we just multiply by 5. But as the opposite to that. So we just take the opposite to the number we're trying to eliminate, multiply to the pivot row, and add and replace to the row we want to eliminate. Right. Again. Like I said, 90% of the math in the class we have to do with the reduced row echelon form. So I just want to do that by hand, at least on these two problems. Right. So row 1 and 3, row 3 changes. 1 and 2 will stay the same. One and 2 will stay the same. Row 3. Right. Just -5 times 1, -5 plus 5, 0. -5 times -2, that is +10 plus 0. -5 times 1, -5 times 1 is -5, and -5, that's -10. -5 times 0 is 0, 10, so that will be 10. Right? So let's check. Pivot 1, good. Everything on that column turn to 0, which is good. Next, we go to second column. Right? Need to get the 1 first. Where's the 1 would be? Of course, echelon form, so have to be below it on the right. It cannot be on this. It cannot be the 10 here. Have to be immediately below on the right. Hence the echelon form. So turn that to 1 and everything else to 0. Turn this to 1. That's easy. Cut everything in half. Even when I teach the lecture class, I will not require you do this on any problem. That takes too much time. And not mention that if you miss a negative somewhere, that the whole problem will completely off. So you have to do extremely carefully. Right. Now, so the 1, which is good, 0 good, so good. Now we have the pivot, which is good. Now we will turn that to 0 and that to 0. When used to it, but we turn that to 0, right? The pivot is at the row 2, so everything will base on row 2. And if we want to eliminate row 1, we're going to add and replace to row 1. What we multiply is just opposite to this number to eliminate. 1 times 2 is 2, plus -2 will be 0. So we use opposite to the number to eliminate. Now, to do this, we use opposite to the number to eliminate. Multiply to the pivot row, add and replace to row 3. Do those 2 steps at the same time. When I do these 2 steps, row 2 will stay the same, so just copy that. Right, now 2 times row 2, 2 times 0 is 0, plus 1. 2 times 0, 1, 2, minus 2. 2 times negative 4, negative 8. Negative 8 plus 1, negative 7. 2 times 4 is 8, plus 0 is 8. Now, negative 10 times row 2, negative 10 times 0 is 0. Negative 10 times 1, negative 10, plus 10. Negative 10 times negative 4, that's positive 40 minus 10. Sorry. Negative 10 times negative 4 is positive 40. Positive 40 minus 10, 30. And negative 10 times 4, negative 40. 10 to the negative 30. On previous section, what we do is we actually, like the last step here, we multiply this by negative 10. And add to row 3. As you see, that's what we have. But in here, I just do everything mentally. Right, now let's check. Have to pivot everything on that column 0, good. Pivot everything on that column 0 is good. Now this needs to be a pivot, so this needs to be 1. To get the 1, usually I just divide by the number, divide by 30, get back to 1, right? Yeah, divide by 30, that would be easy. 1, negative 1. Right, let's check. Pivot 1, everything else on that column 0. Pivot everything that column 0, good. Now we need the next row, the pivot will be here, which is 1, which is good. Now we just need to turn this to 0 and this to 0, and we will done. We'll finish this one. Alright, so now the pivot is on 3, right? So we multiply to row 3, eliminate in row 2, so we will add and replace to row 2. When we eliminate whatever the number, we use opposite to that. If we eliminate negative 7, use 7. Multiply to row 3, add to row 1, replace to row 1. Right. 1 and 2 will change, row 3 will stay the same. Right, row 2. 4 times row 3, 4 times 0 plus 1. 4 times 1 is 4 minus 4 is 0. 4 times negative 1. 4 times negative 1 is negative 4 plus 4 is 0. That's row 2. Now row 1. 7 times 0 plus 1. 7 times 0 is still 0. 7 times 0, so that's still 0. 7 times 1 is 7 minus 7. 7 times negative 1. Negative 7 plus 8 is 1. And this is in the reduced row echelon form. So if we want to, second matrix, reduced row echelon form, apply to the matrix. This is a 3 by 4. 1, -2, 1, 0, 0, 2, -8, 8, 8, 5, 'Right. That's exactly what we have. Reduced row echelon form is unique. After this section, most of the math in this class, we're just going to use reduced row echelon form. So what we had earlier about the echelon form and reduced row echelon form. Okay, just need to know how to do from here to there. Right. So get the 1 first, everything else to 0. That's simple enough. And we have another example here.